video, we already created our login and registration API, and we successfully tested. If you not watched it, just go to this video description and check the link. Okay, from that video you are going to learn how we created the login and registration API, and we successfully tested in Postman. Now in this video we are going to see how we created our disease detection and AI fertilizer recommendation model. Okay, the jurisdiction model is same as the web application that we created earlier. If you are not watched it, and if you are intend to learn about how web application work or how we can create web application in React, you can go through that video also. In that video I explain how to create the CNN model. Okay, so in this video we are not going to go in depth about how we created the CNN model. Okay, it is just the same model as the previous one. Actually I already created the plan model. If you see here, plant disease model, H5 model. Okay, also we created one JSON file also. Using this JSON file we are going to predict our disease. Okay, so this is just a simple CNN model. Where is this model? Okay, this is just a simple CNN model. Okay, if you see here, so this is the code. You will already get the code anyway from you will get one GitHub link. So from that you can use the code. Okay, anyway, if you want to copy if you want to pause that video and if you want to type it, just take a screenshot of the code and you just write your own code. Okay, now here it is, we created a model. Now in our predict.py we created one Flux API. Okay, we created one Flux API, and using that we are detecting our we are creating one API basically. As you see here, predict, we are getting on root, that is predict, and method is post. Basically here we sending one image from our front end to our backend through this API, and backend will generate give us one disease, one confidence, and one advice. If you see here, it will return these three things, and using that root only we are getting that JSON response, and we are going to stringify it in our front end. Okay, this is the simple process, and it is running on the port 400. Okay, 4000, not 400. These are the advices. You can put your own advices according to the disease name, and you can get the disease name from this JSON file. If you see, this is the disease name 1, 2, 3. Okay, so this is predict.py file. Now coming back to our what is a fertilizer model. Okay, just wait a minute. Okay, so for fertilizer we create one CSV file. Okay, this CSV file is created using different model. Okay, different data set. Okay, so here if you see, there is one crop, stage, nitrogen, potassium, not potassium, I think it is P for what I forgot, K is okay. Yeah, nitrogen, potassium, and phosphorus. Okay, nitrogen, phosphorus, and potassium and phosphorus. Okay, phosphorus and potassium, I think. Okay, yeah. Now pH, organic carbon, temperature, rainfall, soil type, fertilizer recommendation. I think this is fertilizer recommendation. Okay, and here also we can get the output in urea base also, DAP base also, like MOP base also. You can create your own output based on your requirement. Okay, but in here in this code, based on the user input of this data, we are getting fertilizer recommendation. Okay, so here if you see in our train.fertilizer.py file, here we load our data set. Okay, and first of all, to create the Python environment, first of all you need to install the Python in our system, right? After that you need to create your environment. If you see here, I create one environment here, virtual environment. Okay, so how to create this virtual environment? Just go to the folder. Now we are inside the src. Here simply write so this way you can create your own environment. Okay, after creating the environment, simply install the packages, package name here. Okay, so this way you can install the packages, and packages we need for this is, first of all you need pandas and zoblib. We need zoblib, we need tensorflow, we need okay, just 1 minute. Yeah, we need sklearn, we need tqdm, numpy, flux, pillow, torch version. Okay, these things we need. You just install it. Okay, this way as I show you, this way you can install it. Okay, now here we function to pass fertilizer recommendation string into numeric value. As you see, these are in the string value, so we need to perform it in the numeric value. Okay, after that we merge into data set. Okay, so after that we train the model, we save the model in the pickle format. After that, in the fertilizer.py file, we create same as the CNN, we create one flux API. Using the API, the root is predict.fertilizer, we method is post, we extract the data from the request and prepare here we prepare the input and we can categorize the data. Okay, after that we prepare the features array. Okay, then we create then we predict the fertilizer that we need to recommend to the user. Okay, so this way you can format the response. Okay, as like you want, you can format like any suppose you want to simply display the UDA, then you can simply display the UDA. You can simply if you want to simply display the like MOP, you can display like this. Okay, or you want to display the urea, you can display like how much urea we need per acre, you can display like this. Okay, this is up to you. So now if you see here, we just to check. Okay, okay, it is sent as image, right? Just do one thing. Okay, if you see here, I already created one fertilizer to test it, to check whether it is working or not. Just do one thing, run the file. Backend is running. Okay, it is running. Now if we method is using post, if I am not wrong. Okay, method is post. Okay, sorry, my bad. To check it, I just need to do one thing. I can't check it using the localhost 6070 because in the app we didn't create the root for it, right? So for that I just need to do one thing. If you check fertilizer, Python is running on this port. Okay, just to copy this port. Now if you see, we get the recommendation for this crop and these details. Okay, so fertilizer is working fine, and predict is, I think predict is running on 400. Just do one thing. If you see, it is give the disease name, confidence and advice also, right? So our predict and our fertilizer prediction is also working fine. Both model AI or our ML model is working fine. If you see here, we give the details, we get the recommendation, we give the image as a input, and we get the disease name, confidence and advice. Okay, so these two things is working fine. Here now we need to do one thing in our app.ts. We need to create our prediction for the both fertilizer and disease detection, and we need to because in mobile application we can't use the Python API. Yeah, we can use the Python API also, but if we are using the 6070 port and we are getting all the requests from this port, so we don't want to use the different port in our single application. Okay, using the same port we are going to get our result. We are going to do the CURD operation using the same port. Okay, so in the next part we are going to create the APIs for the prediction also, and also we are going to check the Flutter application part where we are going to create the login registration page. Also we are going to create the disease detection page, and also we are going to try to create the fertilizer page also. Okay, till then thank you, and if you are not watching the previous part, just go to the video description. You will get the previous video link. From that link just go through the previous video how to create the APIs, so that you will not get confused whenever we are going to connect the API in our front end part. Okay, till then thank you.